Thank you, everybody, for coming here and listen to me today. I am Mauro, and I'm a tech lead in Adevinta. Although I have a lot of experience in software, today I will share with you what I learned as a father. Playing with my kid has been a teaching experience for me because it allowed me to play with my imagination and become what I was when I was a kid myself, a little dreamer. So, if after this talk you feel inspired and you have some questions or you just want to talk, you can ping me on the email. But I wouldn't be here today if it wasn't for my employer, Adevinta. I'm very bad on sales pitch, so I will not try to sell you something I'm not really convinced for. Working for Adevinta for me is being meaningful so far. What I can say as a distinguished thing is that we have a very multicultural environment. We have employees from all over the world. We work in different time zones, and diversity is embedded in our DNA. Nevertheless, we work on what we call re-commerce, which is, I think, the future for sustainability in this polluted environment of consumerism. We are a workforce of almost 6,000 employees, and nevertheless, we are tech specialists at first, with 50% of our workforces being technical experts. So, as a sales pitch, I'm here to say, if you're looking for a job, we welcome everybody of any kind of gender, race, religion, and whatever else you feel confident to be. And without discrimination, I'm here to tell you that we are hiring. And hopefully we will grow together into it. But after I've said so many words about inclusion, I think if you have had opportunity to read the news today or in these days where world is full of conflict, it's a bit of an hypocrisy. Don't recognize this moment as a privilege. So I don't want to create here a political debate where division is the topic, but rather the union. Stay on your belief, but recognize that today we are here as a privileged people. A disclaimer that I'm obliged to do before we enter in this ginormous topic is there's actually a suicide entering in this. So after this talk, you see me changing career, you might know why. It must be a very bad choice if choose to talk about so much information and in such short amount of time. What I want to embrace with you is that I would like that you don't look at the details of this, but rather focus on the storytelling part, the narrative. We will skip a lot of important facts, and we will just embrace the story as it is, just to walk through like a movie into what is the human history and technology. Nevertheless, though, I need to tell you that as a human being, I'm biased, and my culture and education is strongly European. And the problem with that is I have a specific perspective into this. I wish I could deliver to you much more perspective, but what can I do is I can invite you to do your own research and bring your own take on the same topic. So, at the first of everything, and we're going to talk what is data. Well, data stands for datum, which means given, and implies a thing. And the oldest, let's say, interaction with data that we can find is founded in Mesopotamia. And they were clay tokens used to basically identify goods, let's say a sheep or a bunch of grain. And they were used to basically, well, trade. Data, as a fact, is a raw fact. It's a token of truth. And so it can be collected, it can be stored, and it can be analyzed. But in itself, it's meaningless in its context. And that's why it needs to be parsed. It can be in many forms and shapes. It can be music, it can be biological data, and it can be image and audio, and you know what. So what else? What is an interface then? An interface, the meaning of interface is inter, which means between, and from the vulgar Latin means facere, which means doing. The oldest mechanism that I could find as that identifies interfaces, it is the lever. But I'm not sure, actually, because it's very difficult to find an artifact that represents an interface in the broader sense. So if you find one that is more relevant for this analogy, I invite you to tell me. So, between doing. Interface basically then means that it connects two systems. It's in between. And so it can be about the language. For instance, it can be an agreement on how we call certain things. But it can also be into mechanics, like a light switch that you're more familiar with. And then, of course, in the digital area, we have a graphical user interface. And in the computing systems, we have application program interfaces. There is more and more interfaces that we can list here, but we will not have time for it. So the meaning of interface, the purpose is to basically give access to manipulate and interact with the world we are surrounded. Before we dive into the relationship into data and interfaces, I invite you to look into this book. It's called Algorithm and Data Structure. It's equal program. Besides having a captivating title, it's been a pillar in computer science education. And the most interesting part is he understands the complexity and the relationship that we have between algorithms and data. And I'm challenging here to say that the program is actually interfaces. So to jump into, to continue the narrative, we are forced a bit to understand which historical fact we went through it as a humanity to enter in the information era. First of all, we had the binary encoding. So we took pieces of information and we were capable of encoding and decoding at the smallest principles. Then we had electricity and system. We create our circuits in a mechanical sense. And then we had a communication system. In our most modern ways, it's a telegraph, but smoke signals, of course, came before. There is much more to be allied in this journey, but, well, we don't have a lifetime for this. So where I want to start is about binary encoding. So binary encoding was, let's say, formalized by Leibniz. Sorry for the pronunciation. And it was used as a tool to, let's say, justify the existence of humanity through God. So absurdly, today in this world of rationale, one of the stepping tokens that we had to bring forward the humanity and technology was through the imagination of to answer the question, why are we here? So what Leibniz did is he took inspiration from I Ching, which is like say, in the Western world called the Book of Change, which again, since I'm not a theologist, I cannot give you too much information about it. But he took some tokens that he found, and he understood that the language, those characters that you can see, they could basically be decoded and encoded at the mathematical principles with zeros and one. And eventually, he uses to create what we right now use broadly in all our information systems, the binary arithmetics. So to move a step forward and move again in the direction of consuming computation, I would like to reflect the fact that data is mainly consumed through your eyes, through your ears, and so the output of the computing is usually a display. So the way that one of the first stepping stones to interact with the binary data were actually like the segment displays. Segment displays were like, they had the 7 LEDs nowadays. By then it could be cathodes. They could hold 128 states, depending on which states of the LEDs were. And so they were basically made out of 4 binary bits to represent numbers from 0 to 9. We progressed on the ideas of using the 7 segment displays to then display what we call like Latin characters. But we succeeded suboptimally, because letters like capital B will be confused with 8s, for instance. So afterwards, another revolution came in. And it's the cathode ray. Here we managed to put like a tube which had a gun of electron, and we were capable of modifying the ray of electron in a specific position of a screen. And in this way, we were capable of putting a single dot in a sheet and manipulating this fast at a fast rate enough that for the optical illusion, we will create images. And so is the initial of what we call the raster scanning. So to fast forward a bit, otherwise we will never reach conclusion. In the 60s, we start computer graphics through it. Then we have to look into how we represent text into computing in a more like structural way. And ASCII is born as a standard that we could all share. In the same times, networking started be built. And just afterwards, databases starts to be a concept into computing, and more generic state and views into it. In the 70s, computing reaches what we all today have as a graphical user interface. And since we already had systems that you can interact with inputs and outputs, and we have networking, we put it all together, and we had like what we call a POSIX, which was a textual user interface to interact with multiple systems. And to fast forward even more, I thought we could have talk about Windows management and other type of interface that all users are common used to it. We then jump into an era where we didn't want to browse and click anymore. We want to search. And the web and the idea of meshes basically allowed us to enter in this area where you don't browse, you search for things. So if we look at the landscape today, we have a graph or networking data. We have distributed data that you may be familiar with Tor. We have a collaborative software like Google Docs. We have a non-relational databases. We have event system and append-only databases. We have a conflict-free replicated data, which you can might be more for they are CRDT, and the easiest concept that you can maybe relate it to it is like Figma, for instance, uses the technology underneath. And then we start creating blockchain because we had to, let's say, trust. We needed a distributed, shared trust way of looking at it. But we also had spatial data, which allows us to build maps, but also cognitive systems. And many more data structure that I've been in this evolution. But all of that has been a building block of two main algorithm systems that we built. The definition that I take here is from a book that is called The Clever Algorithms. It's basically a book that is a pillar for, let's say, artificial intelligence. And I recommend you to look into it. He divides, Jason Brownlee divides the two categories of artificial intelligence in two. One is a neat AI, which means that you can explain it, that you know why a system works. The other type of artificial intelligence are scruffy AI, which means they embrace randomness. So noise is the main component of what makes them special. And statistical models plays a bigger factor here. So at this point, I want to conclude almost telling you that we are entering the no UI era. I didn't come with this term. I found it back in the internet. I cannot really pinpoint exactly who came with it. But what I can tell you is that we need to learn how to build programs that adapt on noise. So we need to abandon our if conditions that point to specific values, but we need to look into thresholds. We need to understand much more like geographical position of data. Data is becoming much more complicated and has multiple dimensions. And it is context dependent. If you look into NLPs, for instance, you will see what is the challenge there to understanding context. There were beautiful talks yesterday about it. So we cannot rely anymore on predictive outcomes. What does it mean? We barely start to understand eventual consistency. And now we need to embrace that outcome is not predictable. Well, reality seems to be much more chaotic than we anticipated for. But I want to conclude that to make sense out of all of this, you probably need to look back at the stars. You probably need to start dreaming again. And you probably need to start looking at the bigger picture of this. You might need to look again on why do we exist. And maybe you need to do it with the eyes of quantum physics and other discoveries of metaphysics. That was all. Thank you for listening to me. Have a nice day.